Okay, so we've got the present value interest factor of an annuity, and 1 plus r to the power of minus t. What does it mean when we've got a negative power? It's the same as divide of 1 divided by that number with a positive power, right? Okay, so we could also write this as 1 minus 1 minus 1 divided by 1 plus r to the power of t divided by r. Okay, so this part here is now looking a lot more like our discounting function, our present value function. Okay, so we're starting to see that this is popping up again and again and again, and it is the basic building block of most of these functions and formulas. Okay, so I would really encourage you to notice these things and start thinking through the implications and the application of discounting. You might not fully understand every little detail of every single formula, and that's probably okay. But what it is important for you to understand is why this does discount to the present value, and how that will show up in lots of different formulas. And of course, if we use this present value interest factor of an annuity, we can calculate that for a given number of periods and a given interest rate, and then all you do is you multiply that by the annuity payment, or C, we usually call that C, to give you that present value. Okay, so that's a very handy one to know, and I did post up some workings there that you might find helpful in one of the previous weeks. Okay, so what I did want to look at in connection with this is bond valuations. Okay, so bond valuations, this is a handy one because it actually allows us to calculate an annuity and a lump sum, a future value lump sum. Now, obviously with the bond, you just need to take it for granted that the face value is going to be $100. Typically, that's where that 100 comes from in most of the functions. Now, if it says something else, obviously go with that. But assume $100 is the face value, and then your other parameters will be given to you. So let me grab this example here. Okay, so this is question 14 of chapter 6 in the e-text, and alright, how are we going to work this out? We've got Downhill Company, it's currently, so its value is 90.06, so the yield to maturity is given to us, it's 10%. Not one of those tricky ones where we have to do this trial and error to get the yield to maturity. The bonds mature in 8 years, assuming the face value is $100 with annual coupons. What's the coupon rate? Okay, so let's build up this function, this equation. Now, I could just grab the bond value equation, which is 6.1 on page 176 of the text. What I'm going to do is I'm just going to show you how it's built. It's just as easy to do. So let's say bond value here, which we know, but we'll just put it in here as a word there, and we'll replace it in a minute. Well, the first thing we need to do is we need to grab the annuity part of it. The annuity will be calculated using the present value interest factor of an annuity. So we'll just grab that and we'll just plonk it there. Now we've got to multiply that factor by C, right? Okay, so we'll just put a C in there. Now, there's an annuity part of a bond, but there's also a lump sum payment part, so we're going to just add that on too. Now, well, it's going to be this, isn't it? Okay. Now, just for the sake of for the sake of conformity to how we actually display this, we're going to call that T, and this is going to be F, which is the face value, because of course this is the future value of the lump sum payment. Okay, so that's it. That's the function. You go and check page 176 of the e-text. That is what it is. And so as you can see, we're just taking those basic building blocks and we build that function. Okay, so now let's have a look at how we're going to work this out. The bond value we know is, I'll just take it off, supersized. Okay, 90.06. That is the present value of this bond. Now the payments is what we don't know, but we do know everything else. So we have the yield to maturity, the rate. It is 0.1. We know that it will mature in 8 years, so we'll just put that in there. T is 8, and then we'll divide it by 0.1 again, and then plus face value is 100 divided by 1 plus the rate again. I'll just keep the display that 0.1 to the power of T, which is 8. Okay, so now I'm just going to run this over the calculator. Okay, so I've just run the calculator over this one, and as you can see, I've shown my workings there. I made a slight error in the first time I tried it, checked the solution, and then able to pick up where that was, and now that's spot on. So $8.14 is C. If you can't follow any of these workings, I do summarize some of the steps, because I do assume that you've got that knowledge of algebra to get from each of these steps all the way through. If you're struggling on any of them, definitely don't hesitate to ask me, because it'll be a really simple explanation, and it'll give you some knowledge that will definitely help you throughout the rest of the unit. So yeah, that's basically a worked example of question 14 there.